Hi, this is Doug Einstadter. I'm a professor of medicine, epidemiology, and biostatistics. I'm at the Center for Healthcare Research and Policy at Metro Health, and I teach at Case Western. Today I'm going to be talking about confidence intervals. There are many situations where we might want to use results from a sample to say something about a population, or to compare two or more populations to each other. Confidence intervals are one method that allow us to make inferences about a population based on measurements from a sample of that population. Let's say we want to know the average BMI for diabetics in Cleveland. Since it's not possible for us to go out and measure the BMI for every diabetic in Cleveland, we instead select a representative sample of, say, 25 diabetics and measure their BMI. It turns out the average BMI for our sample equals 32.2. Based on this sample, what can we say about the true mean BMI for all diabetics in Cleveland? We might also want to know whether the average BMI among diabetics in Cleveland differs from the average BMI for diabetics in Columbus, which is reported to be 33.8. Based on our sample, Cleveland diabetics appear to have a BMI that is 1.6 less than diabetics in Columbus. Is this just a chance finding due to variation in our sample, or are diabetics in Columbus really heavier than those in Cleveland? Using a confidence interval provides us with a way to answer these questions. The confidence interval is a range of values that we can be fairly sure includes the true value for the population. While we can choose to have different levels of confidence in our sample results, the most common level of confidence used is 95%. In other words, we define the phrase fairly sure to mean that we are 95% certain that our confidence interval includes the true population value. Usually, we will never know if our confidence interval contains the true value. All we can say is that in the long run, 95% of all 95% confidence intervals will contain the true value, and 5% of them will be wrong. Unfortunately, there's no way to know for certain whether we have captured the true value in any given situation. So how can we use the confidence interval to say something about all diabetics in Cleveland, or to compare the mean BMI among diabetics in Cleveland to those in Columbus? In the first case, the computer tells us that our sample mean BMI is 32.2. and that the 95% confidence interval is 28.7 to 35.7. This means we are 95% certain that the true population mean BMI for diabetics in Cleveland is between 28.7 and 35.7. To answer the second question, we are interested in the difference between the average BMI for diabetics in Cleveland and that in Columbus. If the two average BMIs are the same, then their difference will be 0. If they are not the same, then their difference will be something above or below 0. If we ask the computer to calculate a 95% confidence interval for the difference in BMIs between diabetics in Cleveland and Columbus, we get a result of minus 1.6 with a 95% confidence interval between minus 5.1 and plus 1.8. In other words, we are 95% certain that the true difference in the average BMI for all diabetics in Cleveland and that for all diabetics in Columbus is between minus 5.1 and positive 1.8. Because 0 falls within this range, we conclude that the average BMIs are not significantly different. We can follow the same logic for comparing two populations using a relative risk or an odds ratio. However, in this case, to determine statistical significance, we would be looking to see if the value of 1 is contained within the 95% confidence interval. In summary, confidence intervals are important. They allow us to make inferences about the population based on measurements from a sample. A 95% confidence interval means that we are 95% certain that our confidence interval includes the true population value. If a 95% confidence interval for a difference includes 0, then the result is not significant. And if the 95% confidence interval for a relative risk or an odds ratio contains the value of 1, the association is also not significant.